Hi, this is Mr. Yeager. I'm doing just another quick video about net force, kind of in response to obviously some people struggling a little bit with the idea of this particular formula here of F net equals ma equals the sum of forces. Now this is covered in the free body diagram video as well, free body diagram examples. But I just want to try to reiterate based on how I've seen a few people struggle with this. Not everybody is, so some people, if you're getting them right, just continue what you're doing. But this is definitely probably the most difficult area for this particular unit, but one that you can easily, well, hopefully, overcome fairly quickly. So again, this formula people struggle with because I've seen it in plenty of years in the past where people go, okay, well, F net equals mass times acceleration. I usually don't have anybody have any issue with that, all right? What it is it's the sum of forces thing at the end, sigma F, all right? F net will equal the mass times acceleration, but will then equal the actual forces, the sum of the actual forces involved in the problem. And this is usually applied, friction, and tension. I mean, those are going to be usually the most common ones that will show up in that section. Because F net is not a real force. It's just a combination of all of them. F net does not show up on a free body diagram. We do not write F net like this. Okay, that is extremely wrong. All right. So, but we do draw out free body diagrams where we have an applied force going one way and we have a frictional force going back. These are the actual forces acting on the object. And when I add them / subtract them, all right, that will give me the net force, which then goes back and equals mass times acceleration. So all of these things are equal. F net equals ma, which equals sum of forces. I could say F net equals sum of forces equals m times a. They're all exactly the same value. It's just how you calculate it and what's given to you in the particular problem to help you calculate it. All right? And I tell my students, I'm not looking for you to memorize certain sum of forces formulas. Obviously, there's one that are going to come up regularly. Like on this problem right here, this would be F net would equal Fa minus Ff. As we talked about in vectors, when two vectors are perfectly opposed, exactly parallel and opposed to each other, we subtract those two from each other. All right? Or we do say sum because, as I've seen some people do, it's Fa plus Ff, but Ff would be negative, and therefore still you're subtracting. All right? It's still a subtraction. The net force is less than any individual basically force. Okay? Well, maybe less than any individual force. All right? But I don't want you to memorize this, and that's what happens. I see kids go, so F net is equal Fa minus Ff. Yes, in some problems, not always. Okay? Is that what I want to make clear with that? So I don't tell kids memorize F net equals Fa minus Ff. Obviously, be prepared to use it plenty, but that's not the formula. The formula is sum of forces, so it all depends on what's acting on it. So I'm going to do just a couple examples based on a worksheet. All right. Sorry, let me get this going too. Go. Okay. So based on this, okay, I'm going to look at number 4 and number 5. Okay, number 4 and number 5. All right. Now the thing is, like in this problem, you know, if I gave you things step by step, people are solving it. But this is where, okay, let's just solve it with this setup. So you have a 4.5 kilogram box is pushed with a 38 Newton force. It accelerates across the floor at 5.9 meters per second squared. Calculate the force of friction. All right. So what we're looking at here is, again, we always want to start off with a free body diagram. So we have this box. I mean, it says it's on a floor, so it doesn't say it's on a ramp or anything, so basically we can assume it's on a horizontal floor. I'm going to push it with an applied force. This 38 newtons is an applied force, okay? They would say specifically net force if it's a net force, okay? So this is an applied force. This object is 4.5 kilograms, all right? And it's being accelerated at 5.9 meters per second squared. And my question is, what is the frictional force? Frictional should be going opposite. Now, there are other forces acting on this. There's weight and the normal force. But the thing is, this object is only going horizontally, so I only care about the forces in the direction of motion or in the opposite direction of motion. And so my formula would be F net equals m times a equals, in this problem, Fa minus Ff, because these are the two forces that are causing the motion, that are either making it go faster or make it go slower. So, there's my formula, all right? My question is, what is the frictional force? Okay? So, what I feel like most people would do in this problem is we have mass and we have acceleration. Let's multiply those two together. So that would be 4.5 times 5.9. Let me get my calculator here. I'm going to do it right now. 4.5 times 5.9 is 26.55 newtons. This is my net force. Mass times acceleration is net force. Well, that then will equal the Fa minus the Ff. So, I'm going to write it up here, we don't have a lot of space. F net equals 26.55, which will equal Fa. What's my applied force? 38 minus Ff. Solve for Ff. Okay? Solve for Ff. Alright? So, when I do this, I would simply be adding the Ff to the other side. Alright? 26.55 plus Ff equals 38. Subtract 26.55. Subtract that to the other side. And that will give me frictional force of 11.45 newtons. So the frictional force on this is 11.45 newtons. All right? So again, I'll do one more where they give you something different. They might not give you those exact numbers, those exact variables. So we have, but this is the process. F net equals ma equals the sum of forces. This is going to be continued through multiple units. Okay? But there's my answer, 11 newtons. Okay, 11.45 newtons to be more exact. Let's look at number 5 real fast. Okay? A student slid a 1.9 kilogram textbook across the desk. The book's acceleration was 6.5 meters per second squared. The force of friction on the table is 5.6 newtons. What was the magnitude of the force that the student exerted on the book? Okay? So again, we're being given mass and we're being given acceleration. We don't have to be given those. All right? But in this problem, we are. That maybe in a different problem, they give us everything except for the mass, and that's what we're solving for. In another problem, we're given everything except for the acceleration. Okay? But then we will be given all the other information to be able to try to find the final answer. Okay? So if I do this one again, I'm going to do it right above it. Same thing. It's the exact same situation. F applied, F of friction, weight, and normal. I don't care about the weight and normal again still in this problem. Other ones I might. Other ones I might have to use mu equals frictional force over normal. If you watch my free body diagram example video, you'll see me use that one. Again, it just depends on what's given to you. So in order to find the normal, I might need to find the weight, and then I use mu and blah, 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 blah. So this is as I've heard other teachers say, it's like a cyclical problem. What you do is basically you solve for what you can at that time, and hopefully as you continue solving for things, it'll open up you to solving for all the rest of the variables that you need. And it might stop. You might be going around and solve and get to friction, and now all of a sudden you need to find net force. Well, you go back and use the mass times acceleration, et cetera, et cetera. So, you got to be thinking through and going, what could I possibly solve for next in these problems? So let's speed this on up and finish it up here. So my formula is F net equals m times a, which equals the sum of the forces. What forces are causing the acceleration? That would again be the applied force minus the frictional force, because the applied force is trying to make it go faster, the frictional force is trying to make it go slower. And so therefore, I'm going to speed this one up a lot, 4.5 times, I'm trying to do the old problem again, not 4.5, 1.9 times 6.5 equals, this time we're given friction. I'm trying to solve for the applied minus 5.6 newtons. So this would be 1.9 times 6.5. So this would be, I'm going to erase this, 12.35 equals FA minus 5.6. This right here is my net force. I already did M times A. And then all I do is add 5.6. So my answer here is basically 18 newtons. Okay? All right? Again, depending on how you kind of round things off. All right? 18 newtons. 17.95 is what I have. Perfect. Okay? That's just the way it goes. All right? So, that, I mean, I get it. I get that this formula at the top, this F net equals MA sum of forces, is usually the one that I have to keep on, reinforcing with students. Get comfortable with that. All right. Keep practicing with it. Do not memorize stuff like this, F net equals FA minus FF. That will do you nothing on later problems when we actually, when we add angles or inclined planes and stuff. All right. I don't want you to sit there and go, this is how it always is. Obviously, it could be right, but keep on practicing the problems. Keep on keeping an open mind of going, what do you have? What can I solve for? What is available? Because that's how these problems are. And if you haven't yet, make sure you go back and watch the free body example problem, because I do more expansive problems like this instead of just condensing it. Like these were meant to be a little bit shorter. All right? So that's it. Thank you.